What's going on, everybody? So we have two examples for thermochemical equations. This video will cover one of them. And the thing with thermochemical equations, first of all, they're very easy to spot. They just tell you if heat is absorbed or produced, absorbed or released in the chemical reaction, and it's listed as either a reactant or product. And they help you to differentiate between endothermic and exothermic. So our first example is going to deal with rust. It says, the production of iron and carbon dioxide from iron oxide, which is rust, and carbon monoxide is shown on the following reaction. Then we have the reaction, and notice how we have 26.3 kilojoules as part of the products. That means heat is a product. Heat is being released or is being produced. That should tell us what kind of reaction this is. So question 1, precisely, is this an exothermic or endothermic reaction? We said it was produced, it was part of products. So after the reaction happens, heat is released. That is the definition of an exothermic reaction. So we write exothermic reaction. Okay, question 2. Write the heat of reaction for the thermochemical equation. That is very simple. We stated heat of reaction was just delta H, change of enthalpy. So you write delta H. The only thing we have to know is if it's positive or negative. And that's where we use the definition of endothermic or exothermic. We said that enthalpy change for endothermic was always positive, and enthalpy change or delta H for exothermic is always negative. This is an exothermic reaction, therefore we write in negative 26.3 kilojoules. I'm still wondering why I do J's like that. There you go, that's better. Now, question 3. It says, how many kilojoules of heat are produced when 3.4 moles of rust react with an excess of carbon monoxide? If we have an excess, that simply means we have enough for it to react, okay? So I listed these steps on a problem, or better said, an example on the notes. Now we're going to follow the same steps. Step 1, as usual, we write down the given information by the problem. We know the heat produced when 1 mole of rust reacts with carbon monoxide. How do we know that? From the thermochemical equation. Remember, if we don't have a coefficient, that means the coefficient is 1. If it helps you, write it down. If you don't need it and you know is 1, then that's fine. Then we have 1 mole of rust is reacting with 3 moles of carbon monoxide, and 26.3 kilojoules of heat are produced. So we have delta H for 1 mole of rust in the reaction is 26.3 kilojoules. Again, I'll redo the J. And we want to know, so we write unknown. Delta H for, that's when we read the question, 3.4 moles of rust. So 3.4 moles of iron oxide equals question mark. These two are going to help us when we do the cross multiplication. The first thing we write is the conversion factor. Oh, my mistake. And this is from the equation, or you can get it from the given as well. So we write 26.3 kilojoules are produced when 1 mole of rust reacts with carbon monoxide. We turn this into a ratio. Delta H on top, moles on bottom. I'm going to say that again. Delta H goes on top and then moles on the bottom, okay? Now we do the cross multiplication. I'm going to use this space over here. We rewrite the conversion factor. So that would be 26.3 kilojoules are produced per 1 mole of rust. And then cross multiplication with, now we use the information from the unknown. Remember, delta H goes on top. We don't have delta H. That's what we're looking for. So we write just delta H of, or per 3.4 moles of rust. To use red to indicate direction for cross multiplication, although I'm pretty sure you're good with this. So we multiply 26.3 kilojoules times 3.4 moles of rust. That should be equal to delta H multiplied by 1 mole of rust. So I'm going to start with delta H because we need to solve for delta H. So after the cross multiplication, we have parentheses delta H times, we said 1 mole of rust. That's equal to 26.3 kilojoules times 3.4 moles of rust, close parentheses. Now we solve for delta H. First thing is divide by 1 mole of rust because we want delta H by itself. So divide both sides, don't forget, by 1 mole of rust. So 1 mole of rust cancels 1 mole of rust. And notice we can also cancel units over here because we have moles of rust and moles of rust. So we cancel mole Fe2O3 with mole Fe2O3. And then our equation will be a lot cleaner. So on this side we only have delta H is equal to 26.3 kilojoules times 3.4, no units because we canceled them in the previous step, and that is divided by 1, no units because we canceled them in the previous step. And then all we do is the math. And I already did it for you, as you can see. 26.3 times 3.4 divided by 1, which is what we have. And our answer is 89.4. So let's write it in red. Delta H, oh, it's purple, that's fine, is equal to 89.4 kilojoules. Whoa. And we box it. And that's our answer.